Section 2.5, Subtraction of Fractions and Mixed Numbers. Let's try some examples involving the same denominator, or like denominators. 6/7 minus 2/7 is simply 4/7. 6 minus 2, the denominator stays the same. Easy enough. Number 2, 11/18 minus 7/18. Same concept. 11 minus 7 gives us 4/18. Notice that we can reduce 4/18. Both 4 and 18 are divisible by 2, so your final answer would be 2/9. Okay, another question. Find the difference between 16/27 and 7/27. Just as the word sum means to add, the word difference means to subtract. So sum is add, difference is subtract. So we are going to do 16 minus 7. So we get 9/27, which reduces to 1/3. Make sure that no matter what, you write your fractions in lowest terms. Let's try an example involving fractions that have unlike or different denominators. For example, 5/6 minus 1/4. Let's start by finding the LCD between 6 and 4. Take the larger number, 6, do multiples of it, 6, 12, 18, so on. 12 is the least common denominator or least common multiple between 6 and 4. So that is our LCD. Then let's create equivalent fractions. 5/6 needs to be multiplied by 2/2, so that 6 becomes 12. So we end up with 10/12. 1/4 has to be multiplied by 3/3, so that 4 becomes 12. So our new fraction is 3/12. Now we are ready to subtract. 10 minus 3 gives us 7, and the 12 remains the same. 7/12 is the final answer. Let's try this one. Find 5/6 less than 8/9. Anytime you see the phrase less than, it means to flip-flop the order of the numbers in which they appear in the statement. So instead of doing 5/6 minus 8/9, you're actually going to do 8/9 minus 5/6. Think about it. 5/6 less than the starting number 8/9. So we're going to do 8/9 minus 5/6. So again, anytime you see the phrase less than, flip-flop the numbers in the statement. Now let's find the LCD between 9 and 6. The LCD would be 18, because if you do multiples of the larger number, you get 9, 18, 27, so on, but 18 works for 6 as well. So our LCD is 18. Now let's create equivalent fractions. 8/9, we need to multiply by 2/2, so that 9 becomes 18, so we end up with 16/18. 5/6 gets multiplied by 3/3, so that 6 becomes 18, so our new fraction is 15/18. We are now ready to subtract. 16 minus 15 equals 1, so our final answer is 1/18. Okay, let's try 7 1/6 minus 2 5/8. Notice that 6 and 8 are unlike denominators, so we have to find the LCD. The LCD is 24 if you take multiples of the larger number, 8, 16, 24, etc. You get 24. That also works for 6. Okay, so now let's create equivalent fractions. We have to multiply 1/6 by 4/4, so that 6 times 4 equals 24. Our new fraction is 4/24. And then in terms of 5/8, you have to multiply by 3/3, so that 8 becomes 24, so our new fraction is 15/24. Okay, if we try to subtract 7 4/24 minus 2 15/24, we'd actually end up with a negative numerator, because 4 minus 15 is actually -11. So in a situation where this numerator is less than this numerator, you have to do something called borrowing. So let me show you down here. Okay, to borrow, we have to alter the top mixed number, or the first mixed number in the problem. So let's take the 7 and 4/24, split it into 7 plus 4/24. Then what we're going to do is pull one whole, or 1, out of 7. So we're going to split 7 into 6 plus 1, or 6 plus 24/24, which equals 1. The reason I used 24 is because the denominator of our fractional part was 24. Now what we can do is add 24/24 plus 4/24, and we end up with 28/24. So 7 and 4/24 is equivalent to 6 and 28/24. Now, this is not normally okay to do because we have an improper fraction as part of our mixed number, but in order for us to subtract, we must use this borrowing method to get our answer. So we have 6 and 28/24 minus the 2 and 15/24. That does not change. And we get 6 minus 2, which is 4, and 28 minus 15, which gives us 13. So our final answer is 4 and 13/24. Let's try a different example. 5, which is a whole number, minus 2 and 5/8. Okay, what you can do is think of 5 as 5 and 0/8, because 5 plus 0/8 is 5 plus 0, which is 5. A little bit of manipulation. Now, if we tried to subtract, we'd have 5 minus 2, which is fine, but we would have 0 minus 5, which again gives us negative number. So in this case, it would be negative 5. So what you want to do is use the borrowing method. So 5 plus 0/8 can be split into 4 plus 8/8, which again is 1 whole. We're pulling 1 whole out of 5, plus 0/8. Now all we have to do is add 8/8 to 0/8. So we get 4 and 8/8, which is equivalent to 5. So with a little bit of manipulation, we can now subtract. 4 and 8/8 minus 2 and 5/8 gives us 2 and 3/8 as our final answer. Now you try a few problems on your own. Let's see how you do with them. Number 1, what is 21 and 7/9 minus 7 and 11/12? Number 2, 8 minus 2 and 4/13. And number 3, 5 and 5/6 minus 2 and 3/4. Let's take a look at number 1. The LCD between 9 and 12 is 36. Multiples of 12 are 12, 24, 36, 48, and so on. 36 also works for 9. Let's now create equivalent fractions. 7/9 turns into 28/36 by multiplying the top and bottom by 4, so that 9 becomes 36. And 11/12 becomes 33/36 by multiplying the top and bottom by 3, so that 12 becomes 36. Now, in terms of subtraction, if we did 28 minus 33, we'd end up with a negative number, so we have to use the borrowing method. 21 and 28/36. Let's split 21 into 20 plus 1 whole, which we can represent as 36/36, plus 28/36. So our new mixed number will be 20, and 36 plus 28 gives us 64/36. So we have 20 and 64/36 minus the 7 and 33/36. That does not change. So now we are ready to subtract. 20 minus 7 equals 13, and 64 minus 33 is 31. So our final answer is 13 and 31/36. Okay, number 2, we have a whole number minus a mixed number. So let's write the number 8 as 8 and 0/13. So we have 8 and 0/13 minus 2 and 4/13. Again, 0 minus 4 would give you a negative number, so we have to use the borrowing method. 8 and 0/13 can be broken into 7 plus 1 whole, or 13/13, plus 0/13. That gives us 7 and 13/13. So now we have 7 and 13 thirteenths minus 2 and 4 thirteenths. So 7 minus 2 gives us 5, and 13 minus 4 gives us 9. So our final answer is 5 and 9 thirteenths. Number 3 is just a classic subtraction of fractions problem. There's no borrowing involved, and there's no altering of a number. The LCD between 6 and 4 is 12. So 5/6 becomes 10/12. 3/4 becomes 9/12. And then we simply subtract. Again, we don't have to do anything because 5 minus 2 works, and so does 10 minus 9. So we end up with 3 and 1/12.